Okay, we're gonna start the second part of the speech now. But before start, I should announce that due to the power failure for Intel factory, our Intel shuttle bus, the last one should depart at 4:30. So Intel staff, please beware for that. Our shuttle bus, the latest one, should depart at half past 4.
Noboru Iwamatsu, researcher of the Institute of Laboratories Japan. On previous summit at Tokyo and Oracle, I introduced development of parameterized USB driver, PVUSB. Today, I'd like to present the status update of PVUSB. Here's today's contents. I will first present the background and history of this work, and then I will briefly explain what PVUSB is and demonstrate how to use it. Next, I will explain the key changes and some added features of this first release. The first half is mainly targeted at the users, and the last half is for developers. This video shows the example of client virtualization. USB can connect everything from storage to printers, cameras, phones, to just about everything. Now that super speed USB 3 is coming, USB is poised to become the most pervasive high-speed connection method. Using USB devices from virtual machine environment is going to be more and more important. Before PVUSB, they have two options for using USB devices for these domains. The first is using QA disaggregation. This option only provides USB 1.1 function and performance is slow. The second is attaching USB controller by PC group, like your first pattern. This works well, but the entire controller is assigned to a single domain and cannot be used from other ways. So they are not convenient. So we have started development of PVUSB to achieve a good performance and flexibility. Here's our history. On the summit at Tokyo last November, we have reported PVUSB has just started working. On the time of previous summit at Oracle, this June, February, PVUSB have achieved good performance over 30 megabytes per second. After the summit, we have fixed some critical issues and posted it as a first release. Then, PVUSB was merged into the development tree and have been included in 3.4. After that, we posted the update patches, the second release, and we are going to post the extended patch soon. Today, I will talk about these new extended tools and the key changes of second release. At first, I will briefly describe the design of PVUSB. This figure shows the driver architecture. The right part is front-end and the left part is back-end. Linux kernel has 3 layers of USB drivers. The front-end driver is implemented as a USB host controller at the bottom layer. The back-end driver is implemented as a USB device driver, the top layer. USB drivers communicate with USB request block storage called the URB. Red arrow in this figure indicates how URBs are transferred. USB front sends the encoded URBs to backend, to USB back through the link. And USB back recreates it and it transfers to the actual device. The response returns in device sequence. Next is hardware. PVUSB only associates a physical USB device path and to virtual port of the case. PVUSB supports two ways of hot plug, virtual hot plug and real hot plug. Virtual hot plug will manually attach your data to the devices that's already connected to the backend to the virtual port, this way. Specified device is assigned to the guest ports, and specified device 1.2.1 to assign the guest port, and the hot plug is notified. Then attached. Same way. Next is real hot plug. You set the port association rule in advance, and when the device is connected to the appropriate path, hot plug is notified, and the device is attached to the virtual port automatically. I will now explain how to use the PVUSB. Since first release, extended support of PVUSB is lacked. To use PVUSB, it has been necessary to manually set up the Z-score entries. Some guys have created the script for setting up this, but user freedom in PVUSB is limited, has been limited. At last, we are ready to provide extended support. Here is the extend command that create and destroy a virtual host controller. For creating the host controller, you need to specify the USB host controller version, ISP 2.0 or ISP 1.1, and number of root ports. These are examples. Next is attaching and detaching. XM USB attach and XM USB detach are used for both virtual hot plug and virtual real hot plug. You need to specify the domain name, device ID, phone number, and the physical USB device path that already connected or will connect. And now, further, the physical path, physical device path. The physical USB device path is quite a complex thing. It's a combination of path number and port number. This complexity comes from USB spec and Linux kernel themselves, and not PVUSB. But however, we solve it. XMSB list assigned devices is too long, but useful command. This command displays all the assignable devices and the physical paths like SSD outputs. You can easily attach the devices by reading the first column of this output. You can display attachment status of the domain by XMSB list command. If the port is associated with the physical path, it is displayed. In addition, the devices assigned are attached to the port. After the port is displayed within the brackets. Now, let's enter the demo. Here's the desktop. Domain result console and VDC display of guest. First, create the virtual host controller. I create USB 2.0 8 ports host controller. And the message says the backend instance is successfully created. And next is guest console. Open the console and the message. Yes, it said host controller created. Oh. I have a flag. Keeping AC out